Okay, so we are today going to continue on. If you look at the one on the, if you check out the one on the internet, I added some problems at the end. Not a huge number, but I did add about 5 last night. And they're at the very end. And they're a little bit more difficult. I don't know exactly how much more difficult because I didn't try to work them, but I'm looking at trying to get as many different types of problems in there as I can, but workable problems, the ones that we can actually see and work. So we'll see it. We'll see how hard they are. If they're way too hard, we'll give up on them. But I got them out of the Van Valkenburg text, some of them, and some of them I got with that tank circuit I just got off of ChatGPT. So if you want to know where I'm getting these problems from, a variety of sources. But I promise you, I will not give you anything on a test that is more difficult than the questions that you got here. So that's my story, and I'm sticking to it. Okay, so here is another problem like we had before. Initial voltage is 6 volts. And this is number 16, all right? This is where we're at, right? This is where we stopped? This is about where we stopped? Okay, so number 16. And we've got 12 volts. And we've got 2 ohms. And we've got 0.5, I was going to say microfarads, but it's 0.5 farads. We're trying to keep the numbers so that the problems don't get too bad. So anyway, initial voltage across the capacitor is +6. And then you turn this on at t equals 0. So the implication here is at t equals 0, this is really 12 u of t. So at t equals 0, it goes from 0 to 12. But already there was a 6 volts on that capacitor before you turned this thing on. You could have had a switch here. That'd be another way of saying it. But anyway, that's how that's done. Okay, so now let's just work through this problem. And then it asks for the, it wants the voltage across the 6 volts, and I want the voltage across the capacitor. What did I ask for in this one? What did I ask? Do I want the current? I guess I want the current, right? I want the I of the capacitor. I guess that's what I'm looking for. All right. I don't even say what I want, but I think it's what I want. So it's 12 over. Okay, let's go back and start from scratch because that's fair. Okay, let's go back and start this from scratch. So, and do the Laplace in red. So this would be a 1 over, this is 2 up here, and this would be 12 over S. And this would be, have a battery here, and that would be plus to minus. And it would be 5 over S. And this would be 1 over CS, or 2 over S for my resistance. Oh, 6. Okay, 6 volts. I'm sorry. Yeah. 6. So we can look at this and we said 12 minus 6 is 6. So basically our voltage is 6 over S divided by 2 plus 2 over S. And that is my I of the capacitor. And that's probably what I was asking for. Now there are other things you can ask for as well, but basically this would be the first thing to start with. So this would be my current is my voltage divided by my resistance. In this case, this is what you got. So basically, now you got to say 6 over s times, now this would be 2s plus 2. So the s is in the numerator. This would be over 2 times s plus 1. All right, this one goes to the numerator. These cancel out. So it's equal to 6 over 2 is 3 over 1. And that would be 3 over s plus 1. And the answer is 3. The answer in time domain is what? I of t is equal to 3e to the minus what? 1t. That's rule 2. Okay? That's an easy one, right? It's the current. Any questions about that? Okay. Moving on. Number 17. So they just keep going. Like I said, I added some more last night, and I'm not going to add a lot more, but I did add the tank circuit, and I did add the couple, 3 from the Van Valkenburg book. So this is a series circuit. Now, what do you expect here? Just out of curiosity, what are you going to expect when you see that something like this? You're going to see some s squared terms, right? You're going to see, because you got s, you got, this is, let's just look at it and attack it directly. Okay, so now let's do a new. And if you notice, now I pull this over here because when I hit new, if I create it over here, I can pull it back, but I can push it back the other way, and I can expand it, so I can get more out of it. If I need more, I can get it. Okay, so this is number 17, and we are in black. Okay, so number 17. This is 12 volts, and this is 4, and this is 1 Henry, and this is 0.25 farads. Okay, so I want I1. So I do this in red. So this would be 12 over S. This would be 4. This would be what? 1S. This would be what? 4 over S. Now, are there any initial conditions? The answer is no. So basically, I is equal to what? Ethan, what's I?
Or 4 plus 1s is 4 over s.
Very good. Everybody see that? So what do you got to do here? Common denominator, it's 4s, bless you, plus s squared plus 4 all over that. So now that's all over s. That's the denominator. So now you flip it. It's equal to 12 over s times s over, s squared. Here's my s squared. You put the s squared first, plus 4s plus 4. S is canceled out. It's equal to 12 over s squared plus 4s plus 4. Now what do? Minus b plus b squared minus 4ac over 2a, which is a quadratic equation. So now you try that, okay? What does that give you? Minus b, minus 4, plus or minus the square root of b squared, which is what? B squared is 16 minus 4 times 4, or 4ac over 2a is equal to what? Well, you can pretty much look at this and you can say it's equal to s plus 2 times s plus 2, or what? S squared plus 4s plus 4. So this is factorable, and it's very easily factorable into what? 12 over s plus 2 quantity squared. All right? Everybody see that? Use this to figure that out, though. If you can't factor it easily, use this to see whether you're going to find it in the J domain with imaginary numbers, or in the real domain, or if you have multiple whatever. You follow that? Use the quadratic equation to your advantage. Don't just say, well, I got to see if it's factorable, but I can't factor. Use this as your crutch. Okay? S equal that. And this cancels out, and you can see exactly where you're at. Any questions about that? So now you've got this. Now, how do you expand this? Now I can go over here and do this. See what I just did? I made it so I can go over here and make this bigger. So it's equal to what? 12 over s plus 2 quantity squared is equal to what? Oh, by the way, do you have that on your sheet? And you might. This is one you actually might have on your sheet. Do you have this on your sheet? You always got to check. Is it on your sheet?
Over s squared plus 8 squared.
Is this on your sheet? If you can find it, I'll give you a couple points for today. How's that? Look on your sheet, see if you can find it. Always check. Nope. It's on, I'll give you a clue. This one is on your sheet. Look down. Don't go high, go. When they go high, we go low. Go, huh? 23. Yeah, it jumps right out at you after you look at it for about 10 minutes. Okay, 23, rule 23. All right, so what does rule 23 say? What is A? So here you now say A is equal to what? Minus 2. Everybody see that? Okay. What is N? 1. So what is the transform back into the time domain? Well, I'll start with 12. What? T e to the 1 to the minus 2t. And there you go. That's your transformation. Any questions about that? Who's going to win? The t going up or the e to the minus t going down? After a while, what does this function look like? The question is, what does this function look like? If you graph it, it starts to go up and then it comes back down. E to the minus t is going to win, because it's going to take you to 0, minus 2t. But the t term is going to start out looking like, when this is coming, here's my e to the minus t term, here's my ramp function. When you multiply these two together, you get something that looks like that. Does anybody care? But does everybody see how this is done? Because always look on the sheet first. When you get something like this, it's tempting to do the a plus b and all that kind of stuff. And guess what happens? The a term falls out, and this is what you get as a result of it. Okay. Any questions about that one? I didn't realize it when I started, but that's exactly what it is. You always look at the sheet. Always check that your crib sheet first. Okay, number 18. Is this red? You can see where these are going. There's some of these are whatever. Well, let's just keep going, because I do want you to understand that this is a process of basically, I don't want you to just give up and say, I can't do these or whatever. I want you to be able to do these, and I want you to be able to see that you can do this kind of stuff. And, like I said earlier, this is one of those things where the delineation between EECS and EET, they say, well, you can't this and whatever, you can't do that. And this is one of the things they say that we don't do. And daggone it, we do it. And we don't do it necessarily exactly like they do, but we do this kind of stuff, and we do it so that you can understand it, and you can pass your test on your PE test. Okay. So what is the I in this circuit? Zach, right? Tell me what to do first, second, third, and fourth, and fifth, and let's just go through this and figure this one out. So I'm going to do the Laplace transform in red. So tell me what to do first. Yes, 10 over S. Mm-hmm. 1S. One over S. Okay, now what do you do? I is equal to what? Now what do you do? Yep. I'll give you this one. I'll give 2S plus 1, okay? Right. Now what do you do? You cancel this S with that S. Okay, that's how you do next. So it's equal to 10 over S squared plus 2S plus 1. Now what do you do? Hmm? Yeah, you factor the denominator. What is it? What is it? What's the factors in the denominator? How do you figure it out? Quadratic equation. Minus b minus 4 plus or minus the square root of b squared, or 4 minus 4ac, or 4 times 1. And these go away. Over 2a over 2. So what is b squared? Okay. Okay, minus b plus, it's minus b, so it's minus 2, not minus 4, it's minus 2, okay. What is the quadratic equation? Okay, write that on your sheet. S equal minus b plus or minus b squared minus 4ac. So what is S equal here? Minus 2 plus, okay, so S equal minus 1. So it's S plus 1 times what? S plus 1. Okay, and is S plus 1 times S plus 1 equal to what? S squared plus 2S plus 1, and that's exactly what we have. So it's 10 over S plus 1 quantity squared. And again, Zach, is this on your sheet? It's 10 over s plus 1 quantity squared. You're taking the s squared plus 2s plus 1, and you can look at this and you can factor it. Most of them you can look at and factor it. But if you can't or you question it, use the quadratic equation to bust it. Okay? Because, yeah, it's factorable. And it's s plus 1 quantity squared. Yeah. Is this on your sheet? 23. Yeah. Another one. So, what does I equal? Zach. And I of t is equal to what? Yep.
10t.
Yep. E to the minus what? 1t. Okay. Everybody see how this is done? All right, number 19. Everybody get ready because you're going to get your turn. Zach is not the only one going to go in the tank here. We're going to have everybody just do one of these as we go around the room, okay? And I'm not going to tell you who I'm going to pick next, so everybody's got to be ready. So. Okay, number 19. What, by the way, how do you think every one of these is going to turn out? The same, real 23. Every one of these has got the same basic, once you see a pattern, the pattern persists, okay? So number 19 is going to be like number 17 and number 18. Nathan, I want you to work this one.
Okay.
Is that okay?
Yep.
All right.
So,
What's the only thing you got to be careful of? These numbers can actually throw you into a complex, so it can throw you into something that is not, but most of them are going to be kind of a pattern, okay? But what is I for this guy, all right?
12 over s over 3 plus s plus 1 over s.
Okay,
And then you have to get your constant denominator at the bottom. So you have 3s plus s squared plus 1 over s.
okay, so it's 3s plus s squared plus 1 whole thing over s. So you flip that, s in the numerator, 3, okay, so it's s squared plus 3s plus 1 in the denominator, okay?
Yeah, and then the s is canceled, so you just get 12 over there.
Okay. Now what do you have?
And then you have to factor with the quadratic formula.
Okay.
So you get negative 3 plus or minus square root of 3 squared minus 4 times 1 over just 2.
2a or 2. Okay, so it's minus 3 halves plus or minus what?
Um, yeah.
Over square root of 5 over 2. So this is a messy one, isn't it? But it's the same answer.
Yeah.
Any question about that? If you don't believe that, let's do this. Let's say 3s plus 3 plus the square root of 5 over 2 times s plus 3 plus the square root of 5 over 2 multiplied through. So you got s squared plus what? 3 plus the square root of 5 over 2 times s times 2 plus this term squared, 3 plus the square root of 5 over 2 quantity squared. It's messy. No, I think I got it wrong. It should be,
What about the minus?
yeah, there's a minus. One is a minus. I'm sorry. This is I haven't done these in a long time, and I'm messed up. So one is a minus. You're right. Okay, so let's go back and do this correctly. This one is not quite as easy as the other one. All right, so I'll help you here. We'll get through this, but I'll stumble along too. I'll stumble along with do this. But anyway, let's get it. It's s plus 3/2 plus square root of 5 over 2 times s plus 3/2 minus square root of 5 over 2. Okay. All right, so how do you write this one? A over s plus 3 over 2 plus square root of 5 over 2 plus b over s plus 3 over 2 minus the square root of 5 over 2. Okay. Now, you think this is hard, but this is just a number. Okay? This is just a number. So you take 3/2 minus square root of 5 over 2, and that's s plus that, and this is another number. So basically, at this point in time, I would just convert this to a number that you would then put it in there, and then find a and b. Okay? So let's do that. Okay? So I'm not going to try to mess around with this too much. I'm going to say 3/2 plus square root of 5 divided by 2 equals 3.08. So it's just s plus 3.08. And this would be 3 divided by 2 minus square root of 5 divided by, oops, I do not want to do it. No, I don't want to do it that way. I think I messed this up. I think I messed that up. So this is, 3/2, 3 divided by 2 plus square root of 5 divided, okay, square root of 2.61. I would, at this point in time, just say plus 2.61, okay? 0.381. So, again, it's A over S plus 2.61 plus B over S plus 0.381. And now what you do is you let S equal minus 2.61 and let S equal minus 0.381, and you get your A and your B. This is just not nice numbers, but it works the same way. And what's your answer going to be? Nathan, what's your answer going to look like? Something A times e to the minus 2.61t plus some number B times e to the minus 0.381t.
Right.
Okay, you see how it turns? This one actually does turn because of the quadratic equation. All right, so this is the right way to do it. It's been a while since I've done this, but this is exactly the right way to do it. You got to find the A, you got to find the B, and away you go. But that's it. Any question? But they do turn. They don't all fit one model. It basically depends on the numbers that you pick. Okay, so let's do another one. Number 20. And Sarah, do you want to do this one? Number 20. I'll do it in black. Okay, so this is number 20. So you got 12 volts, our good old 12 volts, and 4 up here, and 1 up here, and 0.25. Is this the same as the other one? It's close. Okay, so we're very close in this one. Okay, so 0.25 farads. Okay, so let's do this. Okay, let's do this now in red. So what is our formula? Okay, so I is equal to what? Now what do you do? This is pretty easy. And what's your answer? What does your answer look like in I of t? It's t, 12t, e to the minus 2t. Very good. That's easy. That's pretty straightforward. Yeah. Flip a coin, Ethan, or
I'll do it.
Justin? You ready for the next one? All right. We've got a winner here. We'll see what we got here. Okay, this is they're interesting because you know that the numbers, if they flip, they're going to change things around a little bit. So let's just, okay. Number 21. Okay, let me get it drawn first. So let's do this now. So I'll give you the 12 over S, 6 S, and 1 over S. Okay, so now what is my I? Now the hard part, right? How does this factor?
-6
Minus 6. So S equal minus 6, what?
plus y. 6
B squared, 6 squared, minus 4 times A times C. So 36 minus 4. Okay, over 2A or 2. You got to remember this. Minus B plus or minus the square root of B squared minus 4AC all over 2A. Write that on your sheet. Do not forget that. Keep that near and dear to your heart. Okay? So now, what does this factor into? 6 squared is 36, minus 4 is 32, so it's minus 6 plus or minus the square root of 32 all over 2. What's the square root of 32? Does that come out to anything nice? No, it doesn't. Pardon? Okay, it's force. Okay, very good. Yeah, you can do that. So it's minus 6 plus or minus 4 square root of 2 over 2. So it's minus 3 plus or minus 2 square root of 2. Okay, very good. So S plus 3 plus 2 square root of 2 and S plus 3 minus 2 square root of 2 are your factors. So you can write this as equal to 12 over S plus 3 plus 2 square root of 2 times S plus 3 minus 2 square root of 2, and you're in. Now what do you do? What do you do next? Equal A over S plus 2 plus 3 plus 2 square root of 2 plus B over S three minus 2 square root of 2. Now what you got to do is you got to say let this one all the way through. Let Ted S equal minus 3 minus 2 square root of 2. Let S equal minus 3 plus 2 square root of 2. To get rid of these, make the opposite of these. So it's equal to what? A, okay, so 12 is equal to A times S plus 3 minus 2 square root of 2 plus B times S plus 3 plus 2 square root of 2. So here we go the cross one, and this would be it's messy. This is messy. I'm going to go up here and erase and then do some work up here. So basically, I'm going to erase some of this. Find my A and my B terms. At this point in time, it is perfectly legal for you to just crank in the numbers for these, and that's perfectly legal, okay? Or you can leave it like this. It's up to you. So now we've got 12 is equal to A times S plus 3 minus 2 square root of 2 plus B times S plus 3 plus 2 square root of 2, right? And we let S equal minus 2. So this basically drops out everything. So we get 12 is equal to, if we do this first one, 12 is equal to A times, the 3's go away, and it's equal to minus 4 square root of 2. So whatever that is, that's equal to what? A is equal to minus 3 over square root of 2. All right? Or minus 3 half square root of 2. It's either way. It's up to you. B is now equal, let's get 12 is equal to B times, it's going to be the exact opposite, 4 square root of 2. Or B is equal to plus 3 over square root of 2. All right? So your final answer is what? Minus 3 halves, excuse me, no, it's equal to A, which is, yeah, minus 3 over 2, A, e to the minus 3 plus square root of 2t, that's minus 2 times square root of 2t, plus 3, and this is over the square root of 2, Ted, over the square root of 2, e to the minus 3 minus square root of 2t. Not a nice problem. That's, at this point in time down here, my inclination would be to convert these to numbers, reals, and then the heck with the everything else. That'd be my suggestion. Don't mess around with this 3 plus square root of 2 and 3 minus square root of 2. Get it to a number and then be done with it. Okay? Any question? Not nice.
What you like?
I would, where this is 3 plus square root of 2. Oh, what rule? That is rule, rule 2. This is all rule 2 stuff. Yeah. It's simple. Once you get it to this point, this is rule 2, rule 2. But these are not nice numbers. My point is, at this point in time, what I would do here is to convert this to a real number. Get it to a calculator number, and don't worry about it up here anymore. Just S plus this, boom, splat, and then use those numbers. Even though they're decimal numbers, use them instead of doing all of what I did up here. And instead of S equal minus 3, blah, 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 it'd just be S equal minus 3, S equal minus 5 point something, S equal minus 0.35 or whatever, it'd be done. Like that. Don't mess around. Don't mess with Texas, and don't mess around with this. Just be done with it, okay? Because in a test, you don't have time to fiddle around, and you don't have time, and on my part, checking these out, guess what? One little mistake throws the whole thing kaput, and to give you partial credit becomes very hard to do, but I'm very generous with partial credit, but you know me, I'm a nice guy, right? This is not nice stuff. That being said, you're the good ones because you actually came to class today and actually participated. And Ethan, it's your turn. Sorry about this. Number 22. Ah, what did we do now? Oh my goodness, what did we do here? 10 sine 3t. All right, and then we've got 6. We've got 1 Henry. And one, I, I have a grandson named Henry. We got a Henry. All right, 1 farad. So, what is what's your prognosis of this thing, Ethan?
It'll be 10 sine squared.
Okay, so what is yeah, it's 10 times what? I'm writing this in Laplace. Okay, what
Doesn't the t turn
what
into a square?
what is it?
Isn't it for a square?
What is sine? 10 times 3, right? Over s squared plus 3 squared? Is that right? That's rule number what? That's sine. Yeah, that's sine. That's exactly what it is. Everybody see that? That's rule number 7. Yeah. Everybody see that? This is not going to be a nice one. You already got the clue. This is not going to be nice because now we added that complication on top of everything else. All right, what is this?
6.
Yeah. Now, what is I of I? What is I equal?
30 over square plus 6 squared. 6 plus.
Okay, so now you've got 30 over s squared plus 9 times s
Square plus 6 plus 6.
plus 1. Okay, yeah. Now you start. So what are you going to do over here? Yeah, use the quadratic equation. Minus 6 plus or minus square root of b squared, 36 minus 4ac. So this is a is 1, c is 1, so it's not a word 2. Minus 3 plus or minus what?
Square.
This is 36 minus 4, 32. So it's 2. It's 4 square root of 2 under the number. You take it out. It's 4 square root of 2. Okay, so this is the same number that we had before.
Yeah.
So it's s equal that. So s plus 3 plus 2 square root of 2 times s plus 3 minus 2 square root of 2 are my two factors. Any questions so far? Now, what's the hard part?
Equation would be 30 over square plus 9.
How do you how do you split this up? This part is easy. It's a over s plus 3 plus square root of 2 plus b over s plus 3 minus minus 2 square root of 2, Ted. Gotta erase that. Gotta erase it. How do you split this up?
S plus 3, S minus 3.
Okay. Try your quadratic equation. Minus b plus or minus square root of b squared minus 4ac or 2a. There is no b. B squared is 0 minus 4ac minus 4 times a times c is what? 36. So basically you go back to the square root of this, which is 3.
Plus 3.
Yeah, but it's what? What are my two numbers in here? If I factor this, it's s plus 3j times s minus 3j.
Okay.
Yeah, use the k. Very good. Very good. Can everybody solve this now? Yeah. How do you solve it? Let's finish it off, because this is where you're going to have to finish these problems. You can't stop here. Unfortunately. How do you do this now? Okay, so we say what?
30.
30. Okay, so I'm going to erase this stuff up here, and I'm going to start. I'm going to go back, and we're going to erase all this stuff up here, because now we're down to this point, so we can kind of get rid of all this stuff. $30 equals a times what?
S plus 3 plus 2 square root of 2.
Minus 2 square root of 2 plus b times s plus 3. Oh, and also it's got to times all that other stuff. Yeah, so it's, yeah, I forgot all that other stuff. I got to go back. Yep. And I'm just going to write it as s squared plus 9 plus b times s plus 3 plus 2 square root of 2 times s squared plus 9 plus k, what?
It'd be S plus 3 minus 2
It's,
times.
right, this is the, yeah, this is
That's a.
this is the s squared plus 6s plus 1 times s minus 3j plus k star s squared plus 6s plus 1 times s plus 3j. All right? Find those four values. Now, all you got to do is for a, what do you got to do? You got to say let s equal minus 3 minus 2 square root of 2. And the rest of them all drop out. And the only thing that's left is minus 2 square root of 2 times 2. So for a, minus 3 minus 2 square root of 2, and then you get all this drops out. Excuse me, Everything else drops out except for this term and this term and this. But it ain't nice, but it's doable. Then for the B, that's for A. For B, let S equal minus plus 2 square root of 2. For K, let S equal minus 3J. And it ain't easy. Okay? Will he ask one like this? The answer is, I don't know. Probably one. But you now see how to do it. It's just cranking, turning the crank and getting all the way through it. Can it be done? Yes, it can. It's just tedious. This one is just tedious. But can you imagine how hard this would be with numbers times 10 to the minus 6th and 10 to the minus 4th and all that kind of stuff? If you use simple numbers, at least you get to be able to go through the process. But with hard numbers, these become impossible from the word go. All right, that's number 22. We're slowing down. Has anybody noticed that we went through 15 the first day, and now we're almost done, and we've done 7, and we skipped 1? What does that mean? The further you go, the harder they get. There's no doubt about it. The further we go down this list, the more stinko they get. Now, what about this one? And everybody's going to say, I don't want to come to class. I'll just listen on the video because he's going to ask me this in class. So why even come, right? But on the other hand, I'm glad you're here. If there was nobody here, I don't have anybody to talk to. So thanks for coming. By the way, real life problem. Ethan, we've got those pumps and those sump pumps, okay? Now they have a capacitor across them. They've got a little capacitor that goes across the leads to that motor. So you got an inductor for the motor. You got this, and then they basically. I think it's not in series. I think it's in parallel. So I think I better go back and do it again. So it's in parallel. So I've got a motor lead, and I've got a capacitor. Okay, it's a little capacitor down in there. But what happens is, because we send it a signal that is a pulse width modulated signal, these have harmonics. So the harmonics are high frequency, and this lowers this. At a high frequency, this,
Shorts it.
it makes it shorted. Yeah, it makes it look like there's a lot of current going through here. So what we got to do, put a choke in front of it. But it's got to be sufficiently, you can't just go in and get a little inductor with a little bitty wire because it'll burn it up. So you got to get a choke in front of that, an inductor. So that's got to be put in front of that when we do replace those. If you have time, if not, Tom, whatever. But that's how to fix that. Everybody follow that? Pulse width modulated signal has in it high frequency signals. This is one of the reasons why the thing about when we get through with this part of this course and we're talking about Fourier transforms, Fourier analysis, we look at everything in terms of it's a series of sine waves. Every periodic wave is a series of sine waves, and some of them are high frequency. And high frequency, this will short out, which gives you a lot of current, which heats this up, which destroys it. So we've got to put a choke. Now, the reason that they work, some pumps work, or bilge pumps work, is because usually you put a battery across this. Batteries don't have this, they just are a flat waveform. Easy to do. But we're not using it that way, we're using it with this kind of waveform, so we've got to put a choke in front of it. Okay? Did everybody follow that? Because that's exactly what you got to do. This is for a lab upstairs, but in general, oh, and by the way, the other thing is you could take the capacitor out, you could just take it out and clip it out. What do you do then? Because this is going in water, when you take it apart, you destroy the integrity of the, they basically glue everything in place as they make these bilge pumps. So if you take it apart, what have you done? You've destroyed the integrity of the motor. So it will get wet and then it'll not work. So, are there real world problems that you can solve using some of this stuff? Yeah, right there is one of them. Not a biggie, but now we got to find one that'll work. But it's got to have enough current capability that it will actually support that motor. You see, when do you think these things up? I thought about them when I was in the bathroom this morning. So that was my morning, whatever. Okay, enough of that. Why did I think of that 10 years ago, right? And people say, well, that's pretty smart. No, that came way late because I should have been able to do that a long time ago. This is number 23. This will be the last one today, so I'll do this one and I won't put anybody else under the gun, and you can all relax, take it easy, and you can tell me when I'm making a mistake, and we'll finish this off and we'll be done, okay? So be thankful for little things. Not that I'm trying to beat you up, but I do think that this is one of the ways we can get this stuff working. Okay, so this is just a straight old 10, 6, 1, and 1s, and 1 over s. So now I've got I is equal to 10 over 6 plus s plus 1 over s, which is equal to 10 over, or 10s over s squared plus 6s plus 1. And now we are pretty good at this, so we can say b squared minus 4ac, which is, this is 10, so equal to 10s over s plus 3 plus, what is it, 2 square root of 2 times s plus 3 minus 2 square root of 2. So that's how that's done. Okay, so now how do you factor this? Easy. 10s is equal to a over a times s plus 3 plus 2 square root of 2 plus b times s plus 3 minus 2 square root of 2, and we let s equal. So this factors into a over something plus b over something else, and these are the two factors. Okay, so let s, and I didn't write them out, but that's what it, s plus 3 plus 2 square root of 2, s plus 3 minus 2 square root of 2. And at this point in time, I am going to do the novel thought of getting 3 plus 2 square root of, 3 plus 2 square root of 2 equals 5.828. And I'm just going to say this is s plus 5.828, and 3 minus 2 square root of 2 equals, or 0.171. S plus 0.171. So let S equal minus 5.828. Let S equal minus 0.171, and I'm in. Don't mess around with those other numbers. Do it like this. Okay, so now I've got 10S is equal to A times S plus 5.828 plus B times S plus 0.171. And I say, let S equal minus that. This term drops out. I say, so it's 10. So for the first one, for A, excuse me, for B, 10 times minus 5.828 is equal to B times minus 5.828 plus 0.171. What is that? And that's how you find A. That's how you find B, and that's how you find A, and you're done. Don't mess around. Okay? I don't know the final answer, but that's how you do it. Any questions? Any comments? Let's see where we're at. Number 24 is the next one, and this is a mess because what did I just do? Current supply, yeah. All right, so now we're down to the really messy ones, and yeah. So I'll hit you with the quiz question, but basically is any two that you want to work, and that'll be emailed to everybody, but that'll be, any two that you want to work out of this. You pick them, work them, get them through the answer and all that kind of stuff. And that'll be on, what, Wednesday of next week? Any questions? I'll take homework if you got it, and thank you.
This is the quiz that was done today.
Thank you. That's very good. That's very good. Thank you. Take care. Have a good day.